why nobody can fix this New York skyscraper from a YouTube channel called The Impossible Builds. I recommend you guys go check them out. They make really good construction videos. So if you're someone who's interested in infrastructure, I think that's a channel that you should be following and watching their videos. Let's dive in and find out.
See this tower? It dominates New York City's downtown skyline, a sleek glass giant meant to command million-dollar views of the East River. At first glance, it seems like another impressive addition to an ever-evolving skyline.
Yes, from what I've heard and my own research, I think New York is one of the best skylines in the world. So I agree with him on that one.
Look again. Something's not right. The tower isn't standing straight. It's leaning, visibly tilting away from the street below. This is...
Before we even go any further in this video, I can go ahead and guess with 99.9% certainty that this is going to be a foundation problem.
One Seaport, a luxury tower that was meant to be a symbol of ambition. Now, it's an abandoned eyesore, a multi-million-dollar testament to a construction nightmare. Lawsuits swirl, engineers scratching their heads, and potential residents turn away in disbelief. How did a state-of-the-art skyscraper end up tilting before it was even finished? Look closely at the eastern edge of Lower Manhattan, where the bustling financial district gives way to the East River. Here, on a narrow strip of land, stands 161 Maiden Lane. It looks like any other sleek skyscraper, but this site has a story older than the skyline itself. Centuries ago, this building wouldn't have stood on solid ground. It would have been underwater. Landfill in the
That whole area of Manhattan is reclaimed land. Back in the days, that was all seawater, and I think there was a port somewhere around there. They had to bring materials from somewhere else, which is something that has been done in many other places as well. The Dutch are really good at land reclamation projects. They have like a crazy percentage of their country is reclaimed land from the North Sea, if I'm not mistaken. The problem with land reclamation is, number one, the material is not as strong as naturally made ground, and it will take years and years for it to be stable enough to hold big skyscrapers like this.
18th century pushed the shoreline outwards, creating space for a thriving maritime hub. Ships lined South Street, known then as Packet Row, their masts like a dense forest against the backdrop of a growing city. But as the shipping industry declined, this waterfront became a ghost of its former self. Grand plans were floated, a World Trade Center on the river, a neighborhood built atop a submerged highway, even a Frank Gehry designed Guggenheim, but those dreams faded. Now look north. The cobblestones and 19th century buildings of the South Street Seaport Historic District are frozen in time. Just south, massive office towers dominate the skyline. These were the first wave of downtown's transformation. But along the water's edge, something new stirs. A scenic esplanade bustling with walkers and cyclists. It's here, within this patchwork of past, present, and potential, that 161 Maiden Lane staked its claim. This 5,000 square foot plot was destined to become downtown's first luxury residential tower directly fronting the East River. Developer Fortis Property Group bet big, a 60-story glass giant promising million-dollar views. But 161 Maiden Lane wasn't a sure thing. It's been a revolving door of designs, a 52-story slab in 2007, a 175-unit tower in 2010. The price tag kept rising, $41 million, then $64 million as developers jumped ship. This wasn't just about construction, it was about fulfilling the waterfront's long-broken promises. Construction finally began in 2015, or did it? The Department of Buildings slapped the project with numerous code violations. In 2017,
it is really difficult to build in these kind of lands and in this kind of geology as well. It's highly regulated, to get the permits to start construction, your designs have to go through a lot of processes, either with the local council or independent reviewers, which usually will be another different consultancy to go through your foundation designs and the methodologies that you used in making those designs to make sure that everything was done properly and this building won't collapse because of the consequences surrounding something like that if it's to happen in the future.
Slapped the project with numerous code violations. In 2017, a horrific accident claimed the life of a worker, halting progress for months. Yet, the sleek tower continued its climb, apartments selling briskly with those million-dollar views. By 2018, cracks began to show in the facade of 161 Maiden Lane's success story. Literally, concrete rained down onto the street, a sign of construction woes. Delays piled up and the price tag ballooned. The developers scrambled for extra funding, but the real shocker was yet to come. In 2019, the unthinkable happened. The contractor, locked in a bitter dispute with the developer, revealed a bombshell secret. Their measurements confirmed what some had begun to whisper. 161 Maiden Lane wasn't quite vertical. It leaned a surprising 3 inches, or about the width of a smartphone, to the north.
Which is a lot, because that 3-inch tilt will keep on increasing as you build up and up, therefore increasing the overturning moments at the base of the building and putting a lot of uplift forces on the foundations.
So how can a skyscraper end up like this? It all starts with the ground beneath. Think of New York City's bedrock like a sturdy table, the ideal foundation for massive structures. Unfortunately for 161 Maiden Lane, its site lacks that solid base. It sits on landfill created centuries ago when the East River shoreline was extended. Instead of firm bedrock, engineers face layers of sand and unpredictable soil, a much less stable platform. This is where things get interesting. Typically, skyscrapers in Manhattan would utilize systems like deep-drilled piles or caissons, essentially massive columns driven far down until...
Yes, that is the best solution when constructing in such geological formation. Usually, reclaimed lands are made of soft material. The reason being there hasn't been enough time for that material to consolidate and gain in shear strength. So the best way would be to surpass that layer and anchor your building in natural bedrock, which tends to be of high strength. But then that will increase the cost of construction because you have to consider that before you even start the construction, you have to conduct a geotechnical investigation and you have to drill to a particular depth below the proposed foundation base.
Essentially, massive columns driven far down until they hit that solid bedrock. But at 161 Maiden Lane, the bedrock lies between 132 to 166 feet down. Drilling to that depth is incredibly expensive and complex. So the engineers got innovative. Their proposed alternative? A system called jet grout soil improvement.
Yeah, okay. Which is an interesting technique. It's effective, but not all the time. So basically, this is called jet grouting or soil mixing. That's where you inject a cement slurry, then you mix it with the natural soil. Then when that cement hydrates, it hardens, therefore increasing the strength of the soil. But then if the proposed building is heavy, then you have a problem because now you have to consider the weight of that cement grout that you added plus the weight of the building, meaning that the whole section will just settle. Theoretically speaking, that might have been a good idea, but I think they didn't do enough analysis when they proposed this method to see how effective or if it was the best for this proposed site.
Picture this. High-powered jets force a mixture into the sandy soil to a depth of 55 feet, solidifying it and creating a much stronger layer to support the building. On top of this improved layer, instead of piles, they opted for a huge, thick, reinforced concrete mat. Think of it like a giant raft spreading the tower's weight. This system was certainly more budget-friendly, saving the developers roughly $6 million.
You cannot cut corners willy-nilly to save money in construction. That usually will come back and bite you in the future. There is another similar case as well of the San Francisco Millennium Tower. It's facing the same problems, and the last time that I checked, they've been running in 6 and 7s trying to find a solution for it, and now it's at a point where it has costed them more to try to fix it than the money that they could have just invested from the get-go and designed the foundations in a proper way.
This system was certainly more budget-friendly, saving the developers roughly $6 million. However, it introduced a whole new set of challenges. This type of foundation, while adequate, is inherently less rigid than being anchored directly to bedrock. This flexibility becomes a big problem when you have a skyscraper with an ultra-slim aspect ratio, height compared to width, of 15:1, like 161 Maiden Lane. Now, let's talk about wind. Lower Manhattan faces strong winds whipping off the east.
Yes, that's actually something that I forgot to mention as well. So, the problem with this foundation is its inability to adequately resist lateral loads. If you compare the wind forces which the building will be subjected to based on its surface area and the lateral resistance which is going to be provided by that type of foundation, it's not enough. Going back to what I said earlier about if proper analysis had been done, something like this should have shown up in their analysis.
Now, let's talk about wind. Lower Manhattan faces strong winds whipping off the East River. With that slender profile, the tower is prone to swaying and, more significantly, to overturning forces, wind trying to tip it over. The engineers had to carefully analyze how the flexible foundation would interact with this. Picture the swaying of the tower as causing the mat to rotate slightly. Imagine one side of the mat pushing into the soil and the other side pulling slightly away. This is where those 150-foot-long rock anchors come in, drilled down to prevent the mat from lifting. However, even with these anchors, the engineers had to run complex simulations. They looked at what would happen as the building's massive weight gradually settled onto the mat.
Yes, as much as these analysis softwares are advanced, I think we shouldn't forget the fundamentals of engineering. I believe that if you cannot at least solve the problem through pen and paper using fundamental geotechnical and structural engineering equations, then most likely you're doing something wrong or you're trying to do something which is impossible. But sometimes people rush to use these sophisticated softwares, forgetting that the number one rule of using any analytical or finite element analysis tools is that garbage in is equals to garbage out. And I think that these software tools should be used as validating tools, not as designing tools, meaning that everything should be done already using the fundamental limit equilibrium equations. Then you can use the finite element analysis to validate your analytical designs.
Settlement would cause some loss of tension in those anchors. See here, in this figure, demonstrates how much of the mat would lift, and therefore how much additional sway the tower might experience under different conditions. The engineers had to design the tower to be sturdy enough to handle this. The engineers designed 161 Maiden Lane knowing its foundation would be less rigid than bedrock, and they took steps to address this. They calculated that the building would naturally sway more in the wind and made the structure stronger to handle those extra stresses. The sloshing dampers at the top were included to make the swaying less noticeable for residents. However, the actual 3-inch lean isn't primarily due to the foundation design. The most likely cause is uneven settling of the building as its immense weight compresses the soil underneath it.
Settlement is one of the things that we design for, to check if the settlement is below the allowable settlement by the design codes of your area. It's geotechnical engineering 101. Is your foundation strong enough to resist the serviceability loads? Then you move on to the ultimate loads to check the strength, which is when you input your safety factors or you increase the load from the building by a certain margin. Then you decrease the soil strength or rock properties by a certain margin to get rid of those inherent uncertainties of soil. So if a building is settling, then it's definitely a foundation problem, which might be caused by a multitude of reasons. And in this case, I think the design was off from the get-go. The type of foundation that they used, they should have used deep power foundations, considering that other skyscrapers in the area of similar profile are anchored in bedrock. I think that should have been the first solution that they should have looked into.
Imagine the ground under one corner of the foundation mat sinking slightly more than the other side, then another side. This uneven settling would stress the rock anchors differently, causing the mat to tilt slightly and the whole tower to lean in that direction. So, while the engineers anticipated the challenges of the site and designed for increased sway, the lean itself likely results from the unpredictable nature of the ground conditions. This unforeseen tilt set off a cascade of problems. Imagine the ripple effects of this discovery, even before the building was complete. With prices upwards of $1 million per apartment, buyers had snapped up a significant number of units. However, everything changed when the building's lean became public knowledge. The original contractor and the developer quickly found themselves locked in a bitter legal battle, each blaming the other for the problem. It turns out the lean had been noticed much earlier and allegedly caused significant difficulties in installing the sleek glass facade. There were even fears that the tilt could compromise the building's long-term safety, with problems ranging from malfunctioning windows to potential water damage. Despite these troubles, the developer insisted that the project be completed, claiming the building remained structurally sound. But progress stalled, with construction put on hold for years now. The only progress has been redesigning the glass facade to accommodate the building's unintended lean awkwardly. With lawsuits involving multiple parties dragging on, the developer maintained their commitment to finishing the tower, but any specific timeline seems impossible. The once highly anticipated luxury apartments seem destined to remain empty for the foreseeable.
That's the other thing as well. So even if the building is safe from a structural perspective, right, it doesn't change, human behavior and how people feel about that particular building. Not a lot of people would want to invest $1 million in an apartment which the building is leaning. Something like that is really difficult to explain to someone who doesn't have maybe the knowledge of how structures work. If this tilt, right, continues, even if it's still in the acceptable range when it comes to the stability of the building, there's the problem with services. Things like elevators, doors, noticeable cracks in the building will start to show up, which compromises the functionality of the building.
Seem destined to remain empty for the foreseeable future as the legal wrangling continues. 161 Maiden Lane's story is a fascinating look at the challenges of big city building. What do you think? Could they have avoided the lean? Let us know in the comments below. If you enjoyed this video, hit that like button.
This was a great video, and yes, to answer his question, this could have been avoided, but at the end of the day, mistakes like these happen, and the one thing that we can take away from this is they shouldn't happen in the future. Thanks for watching, guys. If you enjoyed this video, please leave a like and subscribe to my channel. And please go check out this channel. I think they make really good videos. I will leave the link to this video in the descriptions down below. Until next time.